Welcome to our MORSLAB presentation, where we break down the required components for building a minimum viable product for our high-power microwave system. Our system is divided into two platforms that carry all of the components. The vehicle platform carries various power sources, while the rest of the components are situated on the gimbal platform. These platforms are connected via bearings and servo motors. Infrared heat signature is picked up by the long-wave infrared camera or the thermal camera. Once the target has been acquired by the thermal camera, the tracking computer generates homing commands to the servos, which continuously aim the antenna and the thermal camera at the target. When commanded to fire, the antenna emits megawatts of microwave pulses, focused directly at the target, capable of destroying or disrupting electronics within microseconds. Starting with the power source, we are using EV battery banks due to their high energy and power density, as well as their availability. An example is the battery banks used in the Tesla vehicle, available from 50 kWh to 80 kWh, capable of operating our systems for days with a single charge. A thermal lens transparent to infrared heat signature is used to project targets onto the thermal imager. The combination of a narrow field of view lens and a high-resolution camera enables target detection at extended ranges. These parts have been secured. Images acquired by the thermal imager are sent to the targeting computer for processing, where computer vision algorithms are used to detect potential targets, such as drones. A single-board computer has been acquired to handle targeting at high speed and efficiency, where it can execute 100 trillion integer operations per second while merely consuming 25 watts. Corrective positioning commands are sent from the targeting computer to two servos, which keep the gimbaled platform pointed directly at the target. High-power precision servos have been acquired, where the combination of high torque and precision enables rapid repositioning with accuracy. A high-voltage power supply is integrated into the vehicle to provide 50,000 volts at several kilowatts to provide power for the MORSLAB generator. This power supply is composed of a high-frequency switching inverter and a transformer, which is then rectified to provide high-voltage direct current. These parts have been already acquired. Current supplied by the high-voltage power supply charges a bank of high-energy, high-power capacitors, and this charges rapidly when commanded. The capacitors have been selected to provide high energy storage and high power discharge to meet the power requirements of the microwave generator, ready to be purchased. Upon command, the MORSLAB generator provides a 400,000 volt pulse at gigawatt level, supplying the vercator that converts the pulse of current into high power microwave. When supplied with a high voltage pulse, the vercator forms a virtual cathode made up of electrons, promoting a resonant oscillation of electron clouds, generating a high-frequency electromagnetic field to be coupled into the antenna. The design of the vercator is ready for prototyping and testing. An integrated pumping station allows the vercator to be evacuated to reach ultra-high vacuums for its operation. The pumping station is composed of a rotary wing pump and a turbomolecular pump in tandem. These components have been acquired and are ready for testing. The pulse of microwave is coupled into the antenna that focuses it into a narrow beam, which gets projected towards the target at high power concentration. The electromagnetic field couples into the target via conductors, inducing hundreds of volts throughout the target, capable of instantly destroying semiconductors. The antenna is under development and is ready to be fabricated via laser-cut stainless steel and machined aluminum. Overall, more than half the components have been acquired, readying us for an MVP to be manufactured in a private lab.